Assalamu alaikum, my dear student. How are you? I hope all of you are fine by the grace of Almighty Allah subhanahu wa ta'ala in this situation. I am Golam Mortuja and I am your physics teacher. Today I will discuss with you chapter 8, which is reflection of light. And here you can see that our today's topic. Number 1, what is convex mirror? Number 2, how the image will form in a convex mirror. Number 3, what is magnification? Number 4, mathematical problem. Dear student, our today's first topic is what is convex mirror. Do you know a convex mirror is a part of a sphere? Here you can see that this is a sphere and the radius of this sphere is r, and a part of it has been cut to make provision for reflection of light from the convex side, that means that side. And now I will show you how the light rays reflects on a convex mirror. Okay, so my dear student, now I will show you how the light will reflect on a convex mirror. Okay, here you can see that if a parallel light beam is incident on the mirror, all the black lines are the incident light rays. Okay, the light will be scattered in all the directions. That means the reflected light will be scattered from all the directions. Here all the red lines are indicating the reflected light. Okay, so if we extend the scattered light at the back side of the mirror, okay, then here you can see that if we extend the scattered light rays towards the center of the mirror, okay, here towards the center of the mirror, it will seem like they have come from a point. That means at that point it seems like that the light will come, and that point is called focal point. Okay, and the center of the surface of the convex mirror where the light ray will reflect, that means the center of the surface of this mirror is called pole. Okay, and the distance between pole and the focal point is called focal length. Here the distance between pole and the focal point is called the focal length, which is expressed by f, and we know that the focal length f equals to radius divided by 2. That means the focal length will be half of the radius of this convex mirror. Okay, I hope you understand how the light will reflect on a convex mirror. Dear student, now I will show you how the image will form in a convex mirror. But to understand how the image will form in a convex mirror, at first we have to understand how the light will reflect on a convex mirror. Okay, and if we know the rules of reflection for 3 special light rays, then it will be very easy for us to understand how the image will form in a convex mirror. Okay, here you can see that I have already write these 3 rules. At first I will read these 3 rules and then I will discuss and describe all of these 3 rules, and I will show you how the image will form based on these 3 rules. Okay, here the first one is if the light rays are traveling towards the center, that means if the light rays extend, here you can see that traveling towards the center, okay, then they are reflected perpendicularly and go back along the line they were incident. That means the reflected ray NX will return where they came from. Okay, and here the second one is if light rays travel parallel to the principal axis, that means the light XP here you can see that XP is the parallel to the YO, that means the principal axis. Then they will appear to have diverged from the focal point F. That means it look like, or it seems like that the light will come from the focal point. The third one is if the direction the light rays is changed. That means if we change the direction of the light rays, it goes back the way it has came when the light rays is traveling towards the focus. It will be reflected parallel to the principal axis PX. That means if the light from Q to P and then the reflected ray will go to the PX. Okay. Now I will show you how the image will form based on these rules. Okay. Dear student, here you can see that an object XY is kept in front of this mirror. Okay. And X is the upper side of this object and Y is the bottom side of this object. Okay. At first, when the light ray is traveling from the bottom side of the object, that means from the Y point towards the center of this mirror, that means towards the O point, according to the second law, the reflected ray will go back along the line they were as incident on. That means when the incident light ray will fall on the R point, that means after that the reflected ray RY will go back where they came from. Okay, that means the reflected ray will be RY direction. And here, to analyze this situation, we can ensure that the image of Y will be created somewhere along the line of OY, but we don't know the actual position of the image. But if we draw the two rays which will come from the X point, then after that, and we can find out the actual position of the image. Okay, so we have to draw the two light rays which will come from the X point. Okay, the first one is when the light ray is traveling from the X point, that means upper side from the object towards the center. Here you can see that the light ray is traveling towards the center. Okay, then according to the first law, the reflected ray will go back where they as incident on. That means the reflected ray will go back where they came from. Here you can see that the incident ray XN, when it will incident on the end point and towards the center, then the reflected ray XN will go back its previous direction. And if we join NX line, then it look like that. For the second ray, when the light is traveling from the X point and parallel to the principal axis, that means the incident ray will be parallel to the principal axis OY. Then the incident ray will incident on the P point, and then according to the second law, they will appear to have diverged from the focal point. That means when the incident ray XP incident on the point of P, at the time it look like that the light is coming from the focal point. Okay, and according to the second law, then the reflected ray PQ will go to that direction. Okay, that is the reflected ray, and XP is the incident ray. Okay, and now we can join FP. Okay, dear student, you can see that the line of FP intersect the line of OX at the point of X prime. That means X prime is the image of X. Okay, we have already get the image of X at the X prime point. Okay, if I draw a perpendicular from the X prime to the main axis, then it will cut this main axis at the point of Y. Then y prime is the image of y. Okay, so this x prime y prime is the image of this xy real object. Okay, here now this x prime y prime is the image of this xy. I hope you understand how to draw an image in a convex mirror. Okay, dear student, now I will discuss with you some characteristic of the image which will be created in a convex mirror. Okay, here you can see that the first one is the position of this image will be between the focus and the pole of the mirror. Here you can see that the image is created between the focal and the pole. That is the focal point and that is the pole. Okay, the further the object is, the closer image to be focused. That means if I move the object far from the mirror, then the image will be created the closer to the focus. Okay, I hope you understand. Second one is the image is virtual. Here you can see that the image is virtual because this is a mirror, and when the object is situated in front of the mirror but the image is created backside of the mirror, then the image will be virtual. Okay, number 3, the image is upright. That means the image is not inverted. Here you can see that if the object is look like that, the image also will look like that, but the size of the image is smaller than the object, but the image and the object is look like same. That's why the image is upright. Okay, number 4, this image is small, and the further the object moves from the mirror, the smaller the image becomes. That means here you can see that the image is smaller than the object. That means, and again, if we move the object far from the mirror, then the image will be smaller than the previous. Okay, I hope you understand these 4 characteristics of this image. Okay, so my dear student, our next topic is magnification. Do you know what is magnification? We have seen that an image can be larger or smaller than the real object, and this is called magnification. That means if we want to know the image is larger than the object or smaller than the object, then we have to use the magnification formula. That means the magnification refers that the image is how much longer or smaller than the object. Okay, here you can see that this is the magnification formula. M equals to L prime by L, where L prime is the length of this image and L is the length of this object. By using this formula, we can easily find out that how much the image will larger or smaller than the object. I hope you understand what is the magnification. My dear student, now I will show you an equation. By using that equation, we can easily find out at which place the image will create. Okay, here you can see that 1 by EU plus 1 by V equals to 1 by F, where F is the focal length. Okay, F is the focal length and EU is the distance of object. That means at which place the object is situated in front of mirror. Okay, and by using this two value we can find out the V. That means at which place the image will create, we can easily find out. Okay, now I will show you a mathematics where I will use this formula and I will find the distance where the image will create by using the distance of object and by using the focal length. Okay, my dear student, now I will try to find out the distance of the image. That means in which place the image will create in a concave mirror. Okay, so here you can see that the distance of the object is 8 cm and the radius of the curvature in the mirror is 12 cm, and we have to find out, that means we have to determine the distance of the image. Okay, here you can see that the radius of the mirror R equals to 12 cm and the focal length F, we know that the focal length F equals to R divided by 2. That means 12 divided by 2 equals to 6 cm. And the distance of the object, here you can see that the distance of the object U equals to 8 cm. And we have to find out the distance of the image. That means V equals to what? If we want to know the distance of the image, then we know the equation is 1 by EU plus 1 by V equals to 1 by F. Okay, I want to find the value of the distance of the image. So I have to change this portion from the left side to right side. Okay, so 1 by V equals to 1 by F minus 1 by U. Why the sign is negative? Because if you change the side, obviously the sign will be changed from plus to minus. Okay, now if I put the value of F equals to 6 cm, here you can see that 6 cm, and U, the distance of object is 8 cm, and if I calculate this equation, then we will get 48 1 by V equals to 2 by 48, or V equals to, we will get plus 24 cm. That means the distance of the object will be plus 24 cm. That means the image will create in front of the mirror, but the distance of the image from the pole to distance of the image will be 24 cm. I hope you understand how can we find out the distance of image by using this equation. Okay, dear student, I hope you have enjoyed the class and you have learned the things which I have already discussed with you. Inshallah, see you on the next class. Assalamu alaikum, my dear student.